Picture this. You're sitting in the exam hall. The timer is relentlessly ticking down. You've got exactly 5 minutes left on your physics paper 4, and you're staring blankly at a 6-mark question on stretching springs. You know the formula, you studied the textbook back to front, but your mind is just completely frozen. The clock is ticking, and here's the brutal reality. Do you know where you just lost 3 easy marks on the very previous page? Look, it wasn't because you didn't know the physics. It's because you didn't speak the examiner's language. So today, we're going to face the painful truth about why students drop entire grade boundaries under pressure, and more importantly, how you can permanently fix it by applying a rock-solid, structured strategy to your answers. Because honestly, ordinary revision fails. You can memorize literally every equation in the syllabus, but if you step into that exam making these fatal learner mistakes, you're basically throwing your grade away. We're talking about the painful stuff. Missing units in your final answer, rounding your numbers way too early in multi-step calculations, flipping your graph axes, or just giving vague, non-scientific explanations, or plotting the entirely wrong variables. These are the classic mistakes that consistently destroy marks. Okay, let's dive into this. We're targeting 2 major areas from your Cambridge IGCSE physics textbook where these mistakes happen all the time. Chapter 4 on turning effects and Chapter 5 on forces and matter. Specifically, we're zeroing in on moments, stability, center of gravity, and stretching springs. These are seriously high-value topics, and to conquer them, you absolutely need a system. So here is your first massive quick win. This is a 4-step answer framework that structurally guarantees method marks every single time you get hit with a descriptive or explanatory question. Step 1, state the core concept. Step 2, provide the evidence or data. Pull this straight from the source material or graph. Step 3, apply scientific reasoning to actually connect that data back to the concept. And step 4, lock it all in with precise examiner wording. When you use this structure, you're physically forcing the examiner to give you the marks. Now listen closely. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious, because knowing the framework in theory is one thing, seeing it applied under actual high-pressure exam conditions is something else entirely.
Let's put a disastrous, super vague student answer about Hooke's law up against a flawless, top-band response. The flawed answer says, the spring gets longer when you pull it, and if you pull too hard, it breaks. Yeah, 0 marks for scientific reasoning there. Now watch the framework in action for a top-band answer. Concept: extension is directly proportional to the applied force. Evidence: as shown in the graph, when force doubles from 2 newtons to 4 newtons, extension doubles from 5 centimeters to 10 centimeters. Scientific reasoning: this demonstrates a constant gradient. And finally, examiner wording: therefore, the spring obeys Hooke's law. Do you see the difference there? It's night and day.
And right there is where your terminology either makes or breaks you. You have to secure definitions like Hooke's law and the limit of proportionality. If you talk about a spring constant but completely forget to mention that the directly proportional relationship only exists up to the limit of proportionality, boom, your score instantly drops. The examiner is literally hunting for those exact words on their mark scheme. Now, what's really interesting about this slide is how easily weak practical investigation skills can cost you. Just take a close look at this data table from a Hooke's law experiment. It looks fine at a quick glance, right? But if you submit this in paper 6 or use it to plot a graph in paper 4, you are leaking marks left and right. So we're going to stress test your data analysis skills right now. I want you to actively pause for a second. Really look at this. Can you spot the exact deadly anomalies in this table that would cost you those easy marks? Look at the headers. Look closely at the numbers. What's missing here? What's inconsistent? Give it some thought. All right, time's up. Here's the authoritative examiner-style feedback. First off, the headers are completely missing units. It shouldn't just say force and extension. It absolutely must say force/newtons and extension/millimeters. Second, look at the decimal places. They are totally inconsistent. You cannot have 2.0 and then 2.15 in the same column if they're measured by the same instrument, right? Your significant figures have to match the precision of the apparatus. To secure maximum marks, your units must be strictly in the headers, your significant figures must be uniform across the board, your graph scales need to occupy at least half the page, and you must explicitly state practical improvements, like taking repeat readings to find an average. Okay, let's escalate the stakes a bit with a much harder example from Chapter 4. This one combines moments and center of gravity. So imagine a bus is tilting on a ramp. The flawed answer says, it falls over because it's too heavy at the top. Once again, incredibly vague and completely unscientific. But if we apply the framework, concept, the bus topples when the line of action of its weight falls outside its base. Evidence. At an angle of 35 degrees, the center of gravity shifts past the pivot point of the right tire. Scientific reasoning. This creates an unbalanced clockwise moment. Examiner wording. Resulting in a resultant turning effect that topples the object. Boom. Maximum marks secured. So the crucial point is understanding that examiner clue I promised you earlier. The ultimate clue is actually the command word right at the start of the question. Command words dictate your scientific reasoning and your data evidence. If the question says state, you just give the fact. Simple. But if it says explain, you absolutely must use that 4-step framework. Describe means tell me what you see in the data. Explain means tell me why it's happening using actual physics principles. Missing the command word is literally like answering a question you were never even asked. So, you've got the ultimate framework now. You know exactly how to structure your answers, how to identify data anomalies, and how to use those command words to your advantage. But we still have a massive unresolved problem. You can have the best framework in the world, but if you're spending 12 minutes on a simple 4-mark question, your time control across the whole paper is completely failing. You are going to run out of time before you even flip to the final page. Because to truly succeed, having a framework just isn't enough. You must pair it with strict, consistent time management. You need to fix this right now. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. To actually solve this massive timing issue, your mandatory next step is mapping out your final 7 days of revision. Having a structured time control system for those final days paces your revision and your actual exam execution so you never, ever freeze with 5 minutes left on the clock again. So I have to ask, will you let poor time management steal the grade you absolutely deserve? Don't let that happen. Take control of your framework. Master the examiner's language, and click the video on your screen right now to lock in your time control system today. Go ahead and click it before the progress bar fills up. See you over there.